So last Friday, due to the weather, we weren't here Monday. We were talking about graphing these equations, the slope and the intercept equation. Something like y equals 2/3 x minus 1. And we graph that starting at the y-intercept, which was the number that's added or subtracted. It's the number that is not multiplying x. That's a -1. So that means from our origin, the center of the graph, we go down 1 unit on the y-axis. So that point is at -1 on the y-axis. From there, then, it's the number that multiplies x that tells us what to do. So 2/3 is multiplying x. That is a slope. And remember, the slope is always a rise over a run. The rise is the top number, the numerator of that fraction, telling us how far to go up or down. So that's a 2. So from this point, we go up 2. And then the bottom number is the run, telling us how far to go over. That is always left to right. So that denominator is 3, so we go over 1, 2, 3. And that is the second point on our line. So our line goes through those 2 points. Well, today I've got a couple of things I want to do. One is I want to look more closely at that slope, what it means. We talked a little bit about it being a rate of change, velocity and stuff like that before. I want to look at what that means and how we find it, and then look at some other forms of equations that we can write based upon that slope. So first, let's take a graph here. Where we have a couple of points. We have a line that goes through a couple of points. And let's say it looks like this. Since I don't have grid paper, I'm going to sketch those little lines in there to help us locate stuff. So we know it goes through those 2 coordinates that I have in blue. The slope, again, being a rise over a run, and we know that the run always goes left to right. So we're going to work left to right on these points as well. The leftmost point is this one here. So to get to the other point, we actually have to rise. We have to go up, and we see that we go up 1, 2 spaces. And then we have to run over left to right 1, 2, 3 spaces. It's the spaces we count, not the lines. So that has a rise of 2 and a run of 3. So that is a slope of 2/3. If we have another line, let's say it has a point there and a point there. And our line goes through those points. So I identified those 2 points that we have coordinates for. Those are coordinate points. Going left to right, okay, the leftmost one is this one here. We are actually rising going down 1. So that's a -1 rise. And we are running 1, 2, 3, 4. So that has a slope of -1 because it goes down 1 over 4. So -1/4 or -1 over 4 slope. If we can derive the slope from the graphs, we should also be able to derive the slope just from the points. So looking back up here, we have these 2 points. The rise here is nothing more than the difference in the y coordinates, the change in the y coordinates. So if this point here is 3, 3, this point here is 6, 5, the y coordinates being the 3 and the 5, yeah, it went up too, went from 3 to 5. The run is the horizontal, that would be a change in x coordinates, in x values. And yeah, we went from 3 to 6. That changed by 3. So that run of 3 fits with that. So from just those coordinates, we should be able to create our slope, to calculate our slope. Slope being rise over run, the rise being the difference in the y coordinates. I'm going to label that as y2 minus y1. Y2 meaning the y coordinate of the second point, y1 meaning the y coordinate of the first point. And then the run being x2 minus x1. So the question is, which point is point 1 and which point is point 2? And the answer is it does not matter. If I have 3, 3 and 6, 5, of course we're beating this one to death a little bit. We know the slope is 2/3, but that's okay. If I take this as point 1 and this is point 2, point 1 has x and y coordinates, point 2 has x and y coordinates. The slope being y2 minus y1 over x2 minus x1. Y2 is 0.2, the y coordinate, that's 5, minus y1 is 0.1, the y coordinate, which is 3. X2 is 0.2, the x coordinate, which is 6, minus x1 is 0.1, the x coordinate, which is 3. So 5 minus 3 is 2, 6 minus 3 is 3. We get 2/3, which is what we had before. Well, what if we switch that around? We chose 6, 5 to be 0.1 and 3, 3 to be 0.2. Well, there's still the x and y coordinates within each. And our slope still going to be y2 minus y1 over x2 minus x1. So y2, 0.2, the y coordinate is 3, minus y1, 0.1, the y coordinate is 5. x2, 0.2, the x coordinate is 3, minus x1, 0.1, x coordinate is 6. We subtract those. 3 minus 5 is a negative 2. 3 minus 6 is a negative 3. Well, a negative divided by a negative is a positive. So it still comes out to be a positive 2/3 slope. So the key is it doesn't matter which point is point 1 or point 2 as long as we're consistent. If x2 comes from this coordinate, or sorry, if y2 comes from this coordinate, x2 has to come from that coordinate as well. So let's do another example or two using other points. We might have negative 3, 7 and 5, 3. I usually just label them as they sit, point 1 and point 2. Of course, x and y, we don't necessarily have to write those in, but we'll do it for now. Our slope, of course, y2 minus y1 over x2 minus x1. So y2, 0.2, the y coordinate is 3, minus y1, 0.1, the y coordinate is 7. x2, 0.2, the x coordinate is 5, minus x1, 0.1, the x coordinate is a negative 3. So we're going to have to be careful here. 3 minus 7, that's positive 3, negative 7 is going to end up at negative 4. 5 minus a negative 3 is the same as 5 plus a positive 3. You add the opposite. So 5 plus 3 is 8. So we've got negative 4 over 8. A negative divided by a positive is going to be a negative. And then the 4 and the 8 both can be divided by 4. Give us 1 over 2. So it is a negative 1/2 or negative 1 over 2 slope. So then with that information, we can look at a graph and write its equation. So I have this line on my graph. I know that y equals a slope times x plus or minus that y-intercept. Well, for this one, the y-intercept is pretty easy to find. That's right here. That crosses at negative 3. The slope is not much more difficult to find. We know we have a coordinate here and a coordinate there. Working left to right, we're going to start at this one. To get to the other one, we rise 1, 2, 3. That is up, so it's a positive 3. And we run, again going left to right, 1, 2, 3, 4, 5. So that is a 3 to 5 slope, which makes that equation y equals slope times x becomes 3/5 times x plus or minus the y-intercept. Well, it's a negative 3, so it's minus 3. If you'd put plus a negative 3, that would also be correct. We have a line that looks like this. Once again, y is equal to the slope times x plus or minus that y-intercept. The y-intercept here again is easy to find. It's right there. That is at a positive 3. We have a second point right there, so we're going to find the slope between them. Going left to right, we're going to start at this one. And we're going to have to go down 1, 2, 3 units. That's a negative 3 rise. Then we run over 1, 2. So the slope is a negative 3 over 2. So the equation here, y equals slope times x becomes negative 3 over 2 times x. Y-intercept's a positive 3, so it's plus 3. So let's look at something a little more technical, applicable. So let's say we have an IV bag. Now obviously we don't have negative values we're going to work with here. This is going to be positive. And let's see here. Let's do gotta be a little bit more careful on my spacing. Let's say this is milliliters in the bag. Down here, this is hours. At the start of this, there's 500 milliliters in the bag. Oops. Let's try that again. And it's empty at 10 hours. So let's find in this the equation that describes the volume of fluid in this bag. So our X is going to be the hours, assuming this is the starting point. This is hours from the start. And Y is going to be that volume of fluid. Well, our Y-intercept here is 500. So Y equals slope times X plus or minus the Y-intercept. 500 milliliters is that Y-intercept. Our slope, well, we have this point here. There's probably several other points we could find along there. Let's just go down to here. We know that's a point as well at 10. This is the point. Now we could just go down the graph, but let's just look at this. This is the point 0, 500. 0 hours after hanging it, there's 500 milliliters in the bag. This is the point 10, 0. 10 hours after hanging it, the bag hits 0 milliliters. So our slope, if I choose this to be 0.1 and this to be 0.2, y2 is 0 minus y1 of 500. x2 is 10 minus x1 of 0. So at 0 minus 500, that is negative 500, and that's technically milliliters. Over 10 minus 0 is 10, and that would be hours. So our slope here of being negative 500 milliliters over 10 hours, we can divide that out. Negative 500 divided by 10 is negative 50 milliliters per hour. So the negative just tells us that the volume is decreasing, getting smaller. A negative rate of change means something is getting smaller at a rate of 50 milliliters per hour. So the equation we have here would be y equals negative 50. I can put my units on there if I want to, milliliters per hour, times x, which is the number of hours, plus 500 milliliters. I would not need to leave the units on there if I didn't want to, but in this case, I'm going to go ahead and do it. Now, to show you that the units work out, let's say I ask, using that model, and that's all this equation is this is a model now that represents the amount of fluid in that bag at each moment in time. How much fluid should be in the bag at 3 hours? Well, let's take a look here. We have that equation. Y equals negative 50 milliliters per hour times x plus 500 milliliters. What this is saying is put 3 hours in for x. So y equals negative 50 milliliters. I'm going to write that over 1 hour per hour. The reason I'm doing that is x is in hours. So this is times 3 hours plus the 500 milliliters. If I look at my calculation here, my 3 hours times the negative 50 milliliters per hour, I have to make that a fraction so that it multiplies out. And I see that the hours will cross cancel. So negative 50 milliliters times 3, that's just negative 150 milliliters. Add that to the 500 milliliter starting point, we are now at 350 milliliters. So again, I put the units in there just so you can see that the units worked out. Now another question we could ask off of that might be, at what time, again, how many, technically should ask how many hours after starting the bag, should the volume be at 200 milliliters? So again, our model, y equals negative 50 milliliters per hour times X plus that 500 milliliters. Well, now we are putting 200 milliliters in for Y. Y represents the volume. So 200 milliliters equals negative 50 milliliters over 1 hour times X plus 500 milliliters. And now we are solving for X. This is exactly like taking something like 8 equals 3X plus 2. We would, in this case over here, you would subtract the 2 and then divide by 3. Well, same thing's going to happen over here. We're going to subtract the 500 milliliters. That's gone over there. On the left side, 200 minus 500 is a negative 300 milliliters. Equals, we've got negative 50 milliliters per hour times X. To get X by itself, now we have to divide by the negative 50 milliliters per hour. Now, since that is a rate, since it's a fraction like that, we're going to multiply by the reciprocal. So it'll be negative 300 milliliters. We're going to make it a fraction by putting it over 1. Then dividing by the negative 50 milliliters over 1 hour, we're going to multiply by the reciprocal, 1 hour over negative 50 milliliters. We see the milliliters cross cancel. Negative 300 times 1 hour is negative 300 hours. 1 times negative 50 is negative 50. And now that divides out. Negative 300 hours divided by negative 50. Negative divided by negative is a positive 6 hours equals X. So at 6 hours, we would expect that bag to be at 200 milliliters. So as we're gathering this information off the graph, there are other forms that we can put the equation in. What we've been using is that Y-intercept form, or slope-intercept form, let's call it. Y equals, as we said, slope times X, and then plus or minus that Y-intercept. So you find the slope and the Y-intercept, and you can create that equation. But oftentimes, the Y-intercept might not be readily available on the graph. We might have something like this. Let's say we know that at 4 hours, let's just write this as 100 units and 200 units. And we're going to label this 5 hours and 10 hours. At 4 hours, we had 200 units. And at 8 hours, we had, let's go 120 units. So we can find coordinates here for slope. This is 4 hours and 200 units. This here is 8 hours and 120 units. So we can find the slope easy enough. Call this point 1 and point 2. Our slope, y2 is going to be the 120, minus y1 is 200. x2 is going to be 8, minus x1 is 4. So we subtract 120 minus 200 is a negative 80. 8 minus 4 is 4. Negative 80 negative 80 divided by 4 is a negative 20. So that's negative 20 units per hour is that slope. But we don't have the y-intercept here. We could go through some work to find the y-intercept. We know y equals the slope, which is negative 20 units per hour. Now to make this simpler, I'm going to leave the units off. We've seen in the previous example, the units do work out. So I'm going to say negative 20x plus. The symbol we often use for the y-intercept is the letter B. So be careful not to confuse that with the number 6. That is a B. We can solve for that y-intercept by using either of these 2 points. Let's use this first one. So that's saying x is 4 when y is 200. So we put 200 in here for y, and 4 in where the x is. So now we're going to solve for b. Combining negative 20 times 4 is negative 80. And then we would add 80 to get rid of the negative 80 to get b by itself. So 200 plus 80 is 280. So b equals 280. That y-intercept is 280. So we combine this back with this equation. So y equals negative 20x. We know that b is 280 now, so plus 280. There's our equation. So we could go through that effort to find b, but we don't have to. There is a form of an equation called point-slope form. In the point-slope form of an equation, all you need is the slope, obviously, and 1 point instead of the intercept. So here, the point-slope form of an equation is y minus y1 is going to be the coordinate of the point, equals the slope, we're going to use the letter m for slope, times x minus x1 is going to be our x-coordinate of our point. So here we had the slope m of negative 20, and we had a couple of different points. I'm going to again use the 4, 200. We also had that 8, 120, and I'll show you in a second that would give us the same equation either way. So I can plug this in here, y minus the y value of my point is 200 equals m, which is negative 20, times x minus the x value of my point was 4. There is a valid equation to describe this. Now you might ask, well, what if we had used that other point, the 8, 120? Well, then our equation would be y minus the y coordinate there is 120 equals, the slope is still negative 20, times x minus the x coordinate there is 8. And believe it or not, these are equivalent equations. Now you could leave either one of them just as they are. That is perfectly legitimate equation. To show they're equivalent, I'm going to convert them both into that slope-intercept form that we've been working with. So I'm going to distribute the negative 20 here. Negative 20 times x is negative 20x. Negative 20 times negative 4 is a positive 80. We've got y minus 200 here. Now I need to get y by itself, so I'm going to add 200 to both sides. Notice I get y equals negative 20x plus 280. That is the slope-intercept equation I had up here before. Right there. Let's look at this other version here and see what happens. So we're going to do negative 20 times x, which is negative 20x. Negative 20 times a negative 8 is a positive 160. And now to get y by itself, we have to get rid of the negative 120. So we're going to add 120. Y equals, and again we get negative 20x plus 280. So you can see we get equivalent equations. Even though they look very different at this point, we get equivalent equations no matter which point we use. So the other side of that is we can actually graph an equation directly from that point-slope form. Let's say we have y minus 2 equals 3/4 times x minus 5. We get a point out of here. Remember, the point that we get out of here is this number, and this has to be a minus. Remember, the formula is x minus x1. That's actually representing a positive 5. The y coordinate is this one here that's subtracted from the y. Again, the formula is y minus y1. So that is actually a positive 2. So the first point we get here is at 5, 2, right there. Well, the slope is 3/4. So from that point, we go up 1, 2, 3, and over 1, 2, 3, 4, giving us the second point on that graph. So our line looks like that. So there's a lot of information we can get out of these graphs and off the lines. We saw the example of the IV bag, volume of fluid in the IV bag. We could look at it from the other side. We could look at the volume of fluid infused into a patient over time. So let's say our flow rate is, let's go at 2 milliliters per minute. I'll set my axes up here. And let's say the bag starts a 600 milliliter bag. So let's show the volume infused into the patient until the bag goes empty. Well, at 0 time, there is 0 fluid in the patient. So that's going to be 0 right there. That's going to be our y-intercept. 2 milliliters per minute, we're going to have to change that. That's 2 milliliters per 1 minute. We want to change it to milliliters per hour. So we're going to put minutes on top, hours on bottom. 1 hour, 60 minutes. Canceling out the minutes, that gives us 120 milliliters per hour. So we go over an hour, we go up 120, right there. Over another hour, we go up another 120. Over another hour, up another 120. Over another hour, up another 120. And finally, over another hour, we're up final 120. This is going to be at 5 hours and 600 milliliters. So we have drained the bag at that point, all 600 milliliters in the patient. We could ask now, of course, we get an equation from that. Y equals our flow rate of 120 milliliters per hour times X plus the 0. There was 0 milliliters in the patient at the beginning. So we could actually leave that y-intercept off. It's implied to be 0. Well, let's look at it from the other side. Let's create the graph if a 1,000 milliliter bag of fluid is infused over 4 hours. We're going to look at the graph in just a second, but let's write the equation. First of all, y equals slope times x plus our y-intercept. Now remember that y-intercept is a starting value. or an initial value. In this last problem, since we're looking at the amount of fluid that's been infused into the patient, and when we started, none had been infused, so that's why that started at 0. In this case, when we started, we're looking at the volume of fluid in the bag. At the beginning, none of the fluid had been infused, so there's still 1,000 milliliters in the bag. The slope, again, is a rate of change, or just a rate. In this case, a flow rate. Well, we can find that flow rate. We have 1,000 milliliters over 4 hours. We're going to leave it as hours. That reduces, we can divide by the 4. To get 250 milliliters per 1 hour. So that's our slope. So that gives us then the equation y equals, now I should be careful, the volume is reducing, is getting smaller, so that's technically a negative 250. The volume is decreasing. This is negative 250 milliliters. That volume went from 1,000 down to 0 in that period of time. So it's, the volume in the bag is negative 250 milliliters per 1 hour times x plus 1,000 milliliters. If I wanted to graph that, it's going to look just like that. Now, again, I can ask questions on this. Now that I have that equation, I might ask, find the volume after 3 hours. So I'm going to put 3 in for x. X, remember, represents the time. So y equals negative 250. Now I'm going to leave off my units here. Times my 3 hours plus 1,000. Negative 250 times 3 is negative 750. Plus 1,000 equals 250 milliliters. So after 3 hours, there's 250 milliliters in there. We might also ask, how many hours until the volume in the bag is at, let's go 600 milliliters. So we have 600 goes in for y now. 600 equals negative 250 times x plus 1,000. And then we just solve that. We're going to subtract 1,000 from each side. So negative 400 equals negative 250 times x. And we divide by negative 250. So x equals a negative divided by a negative is a positive. And what do we have there? 8 over 5. So it's a positive 1.6. So 1.6 hours until that bag reaches 600 milliliters. So the linear modeling is quite powerful, and it does come up quite a bit in our medical fields. There's other things like, time versus concentration, age versus height tend to be linearly related, not perfect, of course. Height versus weight is generally linearly related. For now, we want to be able to look at these basic formulas and to be able to find that slope from those points. On Friday, we'll come back and we'll look more at analyzing those equations. For right now, I want you to look some homework on page 221 through 222, 1 through 15, the odds, and also page 226, 1 through 15, the odds. So this is going to be on graphing and on just finding those slopes and stuff out of those equations. Anybody have any questions? Okay, you guys have a great day, and we'll see you on Friday.